Mindtech is a UK-based startup, founded in 2017. Mindtech have created Chameleon, a complete solution for synthetic data creation and AI data management. This product was launched in 2019. AI systems typically use three elements: a framework, a network model, or the algorithm, and the data to train the network. For a visual application, the data consists of two parts: the images or videos, and the annotations. The annotations are used to describe to the AI system what it is seeing, that is to say, the annotations teach the AI system. A basic annotation may be a simple label such as banana. More sophisticated AI systems are possible, with advanced annotations such as 3D bounding boxes, semantic segmentation and range data. There are a number of issues with traditional sources of data for training AI systems. The conventional method to train an AI system is to film video in the real world, and then annotate by hand. This process is slow, expensive and produces an inadequate supply of accurate data. Mindtech overcome the traditional limitations by creating synthetic data. This has many benefits. Significant commercial benefits occur, as the cost and time to market is significantly reduced. Real data faces significant privacy issues, especially with people and younger children. Understanding the provenance of the data is vital to assuring quality and privacy. As networks and frameworks improve, it is vital to ensure that the datasets keep pace to ensure continuous improvements in accuracy. Synthetic data is especially effective at combating drift, bias and distortions that traditional data introduces. The Mindtech Chameleon Scenario Editor is a simple GUI-based tool for transforming scenes and assets into actionable scenarios for training neural network systems. The sector-by-sector view makes it easy to quickly jump to different areas of the scene. The next step is to add assets to the map in preparation for the scenario. This can be done in three ways. The first shown here is the manual method. This allows the user to add the precise asset required and position it. In order for the simulation to produce useful output, we need cameras in the scene. Cameras can be static or attached to moving objects. Here we show a front and rear view camera being attached to a vehicle. Note the preview of the viewpoint as we add it, which is very useful as we try to assure correct placement. The next camera we add is a stationary traffic light camera. This one we set the height and dip the angle to the required viewpoint. The second way of adding assets is via the auto-populate function. This allows us to automatically fill a scene with a certain density of actors. The fully automated method, whereby assets of certain types are automatically added at runtime through asset source and sinks, is not shown here, but can be seen in operation in the simulation portion of this video. Next we see the scenario editor being used to set up a specific scenario. In this case, a stationary ambulance being set up to deal with an incident in the middle of an intersection. Upon completion of the setup, the scenario is saved. This produces a human and machine readable file that will instruct the fully scriptable simulator of the setup required. The Chameleon simulator takes the scenario editor file to create the simulation. Note the initial view here is exactly as we configured. The simulator can output advanced annotations, including those shown here for demonstration purposes, but usually they would separate files. The built-in traffic simulator allows the car to move autonomously through the scenario. We can cycle through the different cameras we created. These are recorded simultaneously by the simulator. Multiple camera types can be synthesized, including RGB, depth and range. Manual mode allows us full control over the scenario, including changing the time of day. Unique situations such as the crash at the intersection can be easily modeled. The use of synthetic data allows for a reduction in real data, leading to faster time to market at lower costs. Accuracy can be improved, as synthetic data addresses any bias issues in the data set.